parabolas. Now, these are the shapes that you've been studying for the longest, and it's the conic that we don't look at until the very end. We've already looked at circles, ellipses, and parabolas, and now we get back to an old friend, the parabola. You're going to be finding the vertex, the focus, this is something new for us, and the directrix, also something new. These are important items in the definition of a parabola. We'll talk about that in a minute or two. We'll be using this technique, completing the square, again. You never knew it was going to be that important, did you? Then, given certain characteristics, we'll have you find the equation of a parabola. Before we get into that, let's do a little quick review on the hyperbola. We'll do this first one, which looks pretty simple, doesn't it? We know where the center is on this one. It's right here at 0, 0, because nothing is being added or subtracted. Nothing is being added or subtracted. We know it's a hyperbola because we have one positive and one negative term, and because it's the x term that's positive, we know the transverse axis is going to be horizontal. Now, what do we know about the transverse? We know that a squared equals 1, so a equals 1. That means that the vertex of each branch is only one away and horizontally away from the center. For my box that I need for asymptotes, I need b. This is b squared, so b is 2. So that tells me the corner I'm interested in is over 1, up 2, and down 2. So let's change the color of my pen here, and let's see if I can do this pretty accurately. I want to draw the asymptote. That will work here. It's supposed to be a dotted line. And it's supposed to be straight. Of course, you'll use a straight edge to do this, unlike your teacher. So, what have I got? I've got the center. The center is at 0, 0. I've got the two vertices. I don't have the foci. We know with the hyperbola, the distance from the center to the focal point is c, which you find by saying c squared equals a squared plus b squared. Here's my a squared, which is 1, my b squared, which is 4. So c is equal to the square root of 5. Now you could very quickly on your calculator find what the decimal equivalent of that is. I'm just going to estimate it. I know it's greater than the square root of 4, which would be 2 point something, and much less than the square root of 3, which would be 3. So I'm going to say, for an estimate, for graphing purposes, right about there. You probably already have something better than that. So let me see, from the center, 1, 2, just past 2, just barely past 2. And from the center, 2 in the opposite direction, and just barely past that. So those are my foci. Now, it's simple enough, isn't it, for me to, that should be approaching, sorry about my drawing, that should be approaching the asymptote. That one looks a little better. I'm not that good with the stylus. Okay, so this would be a graph, and I actually didn't name what the center, the vertices, the foci. Let's do it right now. The center was at 0, 0. My vertices were at -1 and 0, and +1 and 0. And my foci were at negative, I should be precise here, square root of 5, 0. That was 1 point. And the other one was positive, square root of 5 and 0. Let's do the next one, which looks way more interesting, because where's my center on this one? Maybe I can extend the page, move this up a little bit. Come on. My center will be at 10 and 2, so 1, 2, 3, 4, 5, 6, 7, oh. In this case, I think I will call this 20. Call this 20. Otherwise, I'm afraid I won't have space to graph it. So I'm doing a 2 by 2 grid instead of a 1 by 1. Up here I did a 1 by 1. All right, so my center is at 10, which would be 5 grids over, and up 2, which would put my center right here. Again, I have a horizontal transverse axis. 64 is 8 squared, so it's 8 away, so 2, 4, 6, 8. 2, 4, 6, 8 in the opposite direction. And to form my box for asymptotes, I take the square root of this, which is 9. So it's 2, 4, 6, 8, 9. So my box corner is right there. Right there. Let's do it here too. 2, 4, 6, 8, 9. Whoops. It's a little too low, isn't it? And this one should be right there. All right. Now I'm going to draw those asymptotes. They go through the center and through the corners of those boxes. Should be nice straight lines, which you will draw with a straight edge. Okay. So let me write it out. The center was at 10, 2. The vertices they're both at 2 for the y coordinate, right? But we had to subtract 8 from 10 to give us 8, and then add 8 to 10 to give us 18 for the vertice. And then let's figure out what where the foci are. That's going to be 64 plus 81. So I'm looking at the square root of, add those together, we get 145. Oh my goodness, do I have a perfect square in there somewhere hiding? Oh, if I do, tell me back in class. All right, let me think about this. Well, that's pretty close to the square root of 144. So I'm going to say, at least for my graphing purposes, that this is around 12. This is my estimate. So my focus, let's see, 2, 4, 6, 8, 10. It's going to be right about here. And I go in the other direction, 2, 4, 6, 8, 10, 12. Let's go right about here. So my foci, 2, I know that. And then it's 10 minus the square root of 145. Should have left myself more room. And 10 plus the square root of 145. I've drawn in my asymptotes. I know that my one branch on this side approaching that asymptote. These are very shallow, aren't they? And this one approaching that asymptote. Approaching that asymptote. I apologize for my lousy drawing. So that was almost 12 minutes just to do a review. I think this is probably going to be a double session again. Using geometry to define a parabola. See, remember, when we use geometry, we talk about locus, a set of points. For a parabola, it's the set of points equidistant from a fixed point. We know what to call that, right? Focus. And a fixed line. So let's see if we can figure out what this means. Now the fixed line is called the directrix, and it is always perpendicular to the line of symmetry, the axis of symmetry. So let's test this. This is saying that this distance, let's take this point right here. This particular point, the distance from here to the focus is the same as the distance from here to the directrix. I could choose another point. Let's choose this point here. The distance from that point to the focus is exactly the same as the distance of that point from the directrix. So this set of points that are all equidistant from the focus and the directrix, when you plot them all out, it forms a parabola. The parabola has an axis of symmetry. We know about that. This focus lies right on the axis of symmetry. We know about the vertex. Of course, that lies on the axis of symmetry too. The point midway between the focus and the directrix is an extremity of the parabola. It's an extreme value. We already know this, don't we? Because when we were studying parabolas, we talked about, was it a minimum or a maximum? That's an extremity, right? In this case, it's going to be a minimum value. It's the minimum value of the parabola. We know it as the vertex. What geometric factors determine the shape of a parabola? So this is just asking us to think about what we just studied. What geometric factors determine the shape of a parabola? Now, of course, we know things like the vertex and the axis of symmetry. We came into this lesson knowing that. Whoops. But what actually determines it is a fixed point and a fixed line, which are referred to as the focus and the directrix. So what geometric factors. It's the focus and the directrix. Now suppose you forgot those names. You could say the fixed point and the fixed line. Fixed, that means it doesn't move for any particular parabola. What is the shape of a parabola whose focus is very near the directrix? I think I've got something to help us understand that right here. Well, maybe or maybe not. Let's see what goes on here. That one's very far. I'll look at that one in a minute. Let me draw a directrix. What is the shape of a parabola whose focus is very near the directrix? So the focus is right here, and the directrix is right here. So the focus is not very far from the directrix. What's this point right in the middle here? That's my vertex. So if I go to draw this, we get a shape that looks like this, which is fairly narrow. Now let's try one where the focus is far from the directrix. So here's the focus, and here's the directrix, and I'm going to try drawing it. And of course we know it would be symmetrical and it would go off there. So this is wide. You could think of it also as being shallow, and this one as being deep. So if you were thinking of a mountain valley, very narrow and deep, steep canyon walls, right? This is rolling hills here, just a much wider and shallower valley. So if the focus is very far from the directrix, you're going to have a bowl-shaped parabola. The distance from the vertex to the focus is going to be referred to by this symbol P. So this distance right here, from the vertex to the focus, is P. This gives us a general form for a parabola which has the x term squared, the y term linear. The x term squared equals 4 times p times your linear term. And when your linear term is y, it's a relative of this, isn't it? It's just re-expressed in a little bit different way. This is the one we're familiar with, and this is the one where we have an axis of symmetry that is vertical. We're going to look at some that have an axis of symmetry that is horizontal in just a minute. Here it is. In this case, the y term is squared, and the x term is linear. And this gives you an axis of symmetry that's horizontal. So keep that in mind, that this is the one we're most from. This is our old friend with the x term squared. This is a new one with the y term squared. But the same thing applies with regard to how you define it. It's still the squared term equals the linear term times 4 times p, and p is this distance, the vertex to the focal point. And notice, because how is it defined? This distance is always exactly the same as this distance. P also is the distance to the directrix. So let's try using this. Let's find the directrix, focus, and vertex and draw this parabola. We want to put it in a familiar form here. Well, I guess this is a familiar form. This is a new one here. We want to put it in this form. So I'm going to say x squared equals 8y. That looks a little bit more like it. And I could say x minus 0 squared, right? And I could say y minus 0 as a linear term. And that just leaves the 8. And I want to express that as 4 times p. So I have to factor 4 out of this. 4 times 2. So in this case, what is my p? That's right. So this tells me that the distance from my vertex to my focal point is 2. It also tells me that my center, well, I don't have a center. I have a vertex. My vertex is at 0, 0. So let me draw that in. 0, 0. My focus is up 2. And I know, by the way, I should mark this too. The directrix is going to be horizontal because it's x that's squared. So let me draw in my directrix. And my axis of symmetry comes right down through the focal point, through the vertex, perpendicular to my directrix. What else do I have to do? I guess that would be enough for me to do a sketch. And it'll be something like this. If I wanted to be really accurate, take a little more time. Oh, and this should be symmetrical. Since my drawing doesn't look symmetrical, I'm going to make up for my drawing deficiency by writing in that it's symmetrical. And I could have done some points, and probably should have, but I'm trying to rush us through at least halfway through this. Let me see how many slides I have for us. Where am I right now? Oh, I'm in pretty good shape. I think maybe we'll get through this one and then I will stop. All right. Here we have y squared, so that tells me that my directrix is going to be up and down. And if I rewrite this as y minus 0 squared and x minus 0 for my linear, and 4 times 2, which I have to do to get 8. I know what my distance is from my vertex. My vertex, again, is at 0, 0. My directrix is going to be vertical, because it's y squared. My p is a positive 2, so I move away from my vertex by 2, and I'm ready to draw this thing. Okay? We will get back to this, putting the parabola into standard form. Here's our standard forms. Got two versions of it, right? One where the x term is squared and the other where the y term is squared. This is our old friend. Remember the one we know the parent graph for right there. We're going to stop here for now and pick up part 2 in your next video session. Alright, so 2 progress points for completing parabolas.